let's talk about linear systems. So we are going to look at lines that intersect and find that intersection point or verify that intersection point. So we have several ways to solve linear systems. So linear systems, again, just means one or more lines. So you can see I have two lines graphed here. These are my two equations. So to solve this linear system, I could graph, and I can see that point of intersection is at 3, 4. To verify that, I have a couple of methods. I can use the substitution method, or the elimination method. So those are my two options. So substitute means literally plug one equation into the other and solve. Elimination means we're going to eliminate variables. So probably did this in Algebra 1. I'm going to start with the substitution method. So I can see that my first equation is solved for x. So I'm going to take 2y minus 5 and replace x with it. So in the second equation that says 3x minus y equals 5, I'm going to replace the x with 2y minus 5. So looking at the original equations, we had x equals 2y minus 5 and 3x minus y equals 5, and I took this and put it right there where that x is. All right, now we're going to solve. Can you see that we don't have any x variables anymore? Now we only have y, so we can solve for y. So I'm going to I'm going to distribute 3 through. So I'm going to multiply 3 times 2y and 3 times 5, holding that subtraction sign there. Then minus y equals 5. Now I'm going to combine like terms, and I can add 15 to the other side. So 5y equals 20. Divide by 5, y is 4. All right, now I can go to either equation and plug y in. I'm going to go to the original yellow equation to find x. So I'm going to plug y in and solve for x. 2 times 4 is 8. 8 minus 5 is 3. So I took what I found for y, went back to the original equation, and where there was a y, I substituted the 4. So this verifies that my point of intersection is 3, 4. All right, so that's the substitution method. All right, I'm going to show you the elimination method with a 3 by 3. Now I'm not sure if you've worked with a 3 by 3 before. So by the way, you can do the substitution method on any equation that you want to, like a 2 by 2. It doesn't have to be a 3 by 3. I usually use the substitution method when one of the variables is on a side by itself. So like that one, did you notice that x equals, so x was on a side by itself? That's why I use the substitution method. Okay, but elimination method is a knockout game. So it's kind of like a game. So notice I have 3 equations now and 3 variables. So this is in 3 dimensions. This would be like from geometry, planes. You remember working with planes? So that's what these are. So I have 3 planes intersecting. They can intersect at a line, they can intersect at a point, or they can all 3 not intersect at the same place. That would be inconsistent. That'd be an inconsistent system when we don't have intersection. Okay, so we are going to pair. So I usually number my equations 1, 2, 3. And the goal is to eliminate either x, y, or z. And so I'm going to start out by eliminating z. All right, so I am going to put these 2 equations together, and I'm going to eliminate z. So the goal is that when you add those variables together, you get 0. So I have equation 1 in equation 2, and I chose z because look what's going to happen when I add these together. Do you see I have minus z or negative 1z and a positive 1z? So that's going to make 0. So when you scan these equations, we could have also eliminated x. You can eliminate y. When you scan these equations, you can make it a little nicer, easier on yourself if you'll look for letters, variables that will just add to be 0 to start with. Okay, so now I'm going to add the columns. So 2x minus 1x is 1x. 1y plus 2y is 3y. My z's add to be 0, so I'm not going to write that down. Equals negative 7. Okay, I'm going to come back to this one. So that one just has x and y. All right, now I'm going to pair up. Let's see, how about, doesn't really, we can do 1 and 3, or we can do 2 and 3. So it doesn't really matter. Let's do 1 and 3. So 1 and 3. That says 1 and 3, by the way. Okay, so if I want to get rid of my z's, right now they're not the same number. I don't have negative 1z and positive 1z, but I do have negative 1 and a positive 3. I can multiply equations by anything I want to, just like you did with substitution method. Just like you did with elimination with just 2 equations and 2 variables. So I need this to be negative 3z to add to this one to be 0. So I'm going to multiply the top equation. We have to multiply everything up there by 3. So 6x plus 3y minus 3z equals negative 30. Leave the second equation alone. By the way, you can multiply both equations by something if you need to, but we don't need to this time. So that means like if they're not the same, like if you have 2 and 3, we'd multiply the top one by negative 2, the bottom one by 3, things like that. We'll look at that when I see you. All right, so we're going to add these now because my z's are going to add to be 0. So I have 7x plus 5y equals negative 7. We may get to do that right here. Well, probably not. All right, negative 17, sorry. Okay, so z's were gone. We added straight down the column. So again, you're adding the numbers, the coefficients, numbers that are in front of x. So 6 plus 1 is 7, 3 plus 2 is 5, and then z's are gone. All right, now I'm going to take the 2 equations that I started. So look at these guys. I have x plus 3y, I have 7x plus 5y. There aren't any z's anymore. Remember, we're trying to find a point of intersection, which this time is going to be an ordered triple. So I'm trying to solve for x or y. So let's see what happens here. So I'm going to pick that first equation. So x plus 3y equals negative 7. And I'm going to take the yellow equation, 7x plus 5y equals negative 17. All right, these I cannot get anywhere if I add them. I'm going to get 8x and 8y. That doesn't help me. I need to get rid of x or y. So I'm going to multiply the top equation by a negative 7 to get rid of the x's. Right, so I'm looking at this saying, okay, what can I multiply by x to give me the opposite of 7, right, which would be negative 7. Okay, negative 7x minus 21y equals positive 49, and then leave the second one alone. So 7x plus 5y equals negative 17, and then I'm going to add. So negative 16y equals, what is that, 32? Divide by negative 16. Y is negative 2. All right, so when y is -2, now I can go back and substitute and find x. So see if you can do that. Pause the video. See if you can back substitute. All right, so I'll give you a hint before you do that. So right now I have -2 for y. You can use this equation or this equation to solve for x. So go ahead and pause the video and do that. All right, so now that you've tried it, you better have tried it. I'm going to take -2 and I'm going to replace it right there. I'm using this blue equation. So x plus 3 times -2 equals -7. So x minus 6 equals -7. I'm going to add 6 to both sides. So x equals -1, right? So now I have -1. So now that you have those two, I can find the third one by plugging into one of my original equations to solve for z. And I'm going to do number 2. All right. So number 2 said -x plus 2y plus z equals 3. X is -1. Y is -2. So this makes this a +1 minus 4 plus z equals 3. So -3 plus z equals 3. Add 3 to both sides. Z equals 6. So I have the ordered triple, -1, -2, 6. And that's the solution for that equation. All right, that was a lot. We'll do some problems when I see you again. Drop your questions at the end of the video. Bye, guys.